All right, so we have been talking about systems, finding solutions to systems of equations. Now we're going to talk about inequalities. Okay, so first, before we have any systems involved, let's just talk about graphing a nonlinear inequality. And honestly, this is the same method you'd use for a linear inequality. Okay, so let's just think about what the options could look like. If we have this parabola, x squared minus 4. All right, so it's just shifted down by 4, regular x squared parabola, it opens up, shifted down by 4. Let's think about the 4 different kinds of inequality signs we could have. Right, so here, y is greater than x squared minus 4. Here it's greater than or equal to. Here it's less than. And here it's less than or equal to. Okay? So notice some of these have a dotted line, and some of them have a solid line. Right? The dotted line is if it's just greater than or less than. Okay, so things on this line are not included in the shaded region if it's dotted, right? So like -4, for example, if x is 0, y, if y is -4, -4 greater than -4, that's not true, so it's not included, right? So things on this dotted line are not included in the shaded region, which would be the region that satisfies this inequality. Over here, at this point, -4, 0, -4 is greater than or equal to -4. So this solid line is included in the shaded region of solutions. Okay, so the solution set in this case is the whole shaded region. It's not just a part of the number line, it's a region on the whole graph. Okay, so how would we figure out if we graphed this dotted line here? How would we figure out if we shaded the region inside or outside, right? Is it going to look like this or like this? Here's how we do it. We just choose a point in each region. So like we could choose the origin, right? So is 0 greater than -4? Yes, it is. So this whole region that includes that point 0 would be shaded. And we could choose a point out here like 3, 0, right? So if y is 0 and x is 3, that would be 0. Is that greater than or equal to 5, right? 9 minus 4? Nope. So this region outside here is not shaded. Okay. So this is, if we have equations, there's full regions that are included or not included in the solution set. Okay. So think about these a little bit. So here's the method that I kind of just talked through. So given an inequality bounded by a parabola, here's how you sketch the graph. First, you graph the parabola as if it were an equation, right? This is the boundary for the region that is the solution set. So just like over here, we just graphed in all of these cases as if it was y equals x squared minus 4. Then we decide if the boundary is included in the region, right? So if it's greater than or equal to or less than or equal to, the parabola is graphed as a solid line. If it's not, it's graphed as a dashed line. Okay. Then we test a point in one of the regions to determine whether it satisfies the inequality. If the statement is true, the solution set is the region including the point. If it's false, the solution set is the region on the other side of the boundary line. And we shade the region representing the solution set. So what if we wanted to graph this inequality? Okay, well, first of all, let's just think of this as an equation. Y equals x squared plus 1. So that's just going to be in a parabola that opens up, that's shifted up by 1. So we would graph that parabola, right? We could put in 1 or 2 points to make it as close to accurate as we can make it. It's going to be a dotted line, because it just has a greater than inequality. And now we choose the point. They chose the point 0, 2. And if we put that point into the inequality, if x is 0 and y is 2 greater than 1? Yep, that is true. So we shade everything including that point inside this parabola. And we could choose something on the other side, like 2, 0. Is 0 greater than 5? Nope. So this whole region, right, bounded by that dotted line, is not included in the solution set. All right, so what if we have a system of nonlinear inequalities? This also works for linear inequalities. If we have a system of inequalities, so the first thing you do is find the intersection points by solving the system of equations. Then we graph them. We find the shaded regions of each inequality separately, and the intersection of the shaded regions is the solution to the whole system of inequalities. So let's do an example. All right, we've got this system of equations. First, let's think about this. This is going to be a parabola, and this is going to be a parabola, right? So let's put these. So I guess the first thing we're going to do, let's solve this system as if it were a system of equations, right? If these were equal signs. Let's solve this system to see where they intersect. So the way they chose to do it is by addition, because that's going to get rid of the y's pretty easily, right? So the y's go away. We have 3x squared equals 12. We get, for x squared equals 4, so that we take the square root. Whoops. So we're going to have plus or minus 2 are the two x values. So for each of those, we plug them into the original equation here. So if x equals positive 2, y equals 4. If x equals negative 2, y also equals 4. So we have 2 points of intersection, 2, 4, and negative 2, 4. Okay? And now we're going to want to graph these parabolas. So let's put them in forms. This is the first parabola there. Let's put this in a form that's going to be easier for us to graph. Y equals x squared. That looks pretty familiar, right? I know how to graph that parabola. Here, I could bring this to the other side, negative 2x squared plus 12. So now to graph these parabolas, I'm going to do all the normal things. How would I graph y equals x squared? Well, it's going to be this red parabola here. Vertex is at the origin. I'm going to use a solid line because it's greater than or equal to. And then I'm going to figure out, is it the region inside or outside of that parabola that satisfies this inequality? Well, maybe I could choose the point like 0, 2. If x equals 0 and y equals 2, does this inequality hold? Yes, 2 is greater than 0. So I'm going to shade the region inside this red parabola. Right? So that would satisfy this first inequality. I could also choose a point outside to make sure that, like, I could choose 2, 0. Right? So 0 greater than 4. Nope. So this area outside parabola does not satisfy the inequality with the red boundary point. All right. Now I'm going to graph this second parabola. Okay, first of all, I know, because I solved them, they're going to intersect at these 2 points, negative 2, 4 and 2, 4. Right, so I can mark those. I can factor to find the y-intercept, or the x-intercepts. The y-intercept is going to be 12. I know it opens down because the leading coefficient is negative, right? So I can put that all together, and I'm going to get a parabola that looks like this. And I'm going to use a solid line because the inequality is less than or equal to. Right, so I have 2 solid parabolas. And now I'm going to figure out if the area inside or outside of the blue parabola satisfies this inequality, or this inequality. So let's choose the origin, right? That's inside this blue parabola. Is 0 plus 0 less than 12? Yes. So this whole area inside the blue parabola satisfies this inequality. So the intersection of those shaded regions right here, the intersection is going to be the solution to everything in this area here. This shaded area is the solution to our system of inequalities.